Hello, I'm Hw10. This video is about homework 10, question 1. In this problem, we are going to get the definitions and the properties of several stochastic processes. The first one is Poisson process. First, we need to get the Poisson distribution, which is P, number of calls received in the T hours, equals to K, equals to this function. And in the Poisson distributed, which T is fixed, and where lambda is the average range. If T is not fixed, then it is a function of both T and K. It is a stochastic process. We define Poisson process xt as follows. x0 equals to 0 and xt1 minus xt2 equals to the number of calls received in t1 and t2, with p xt1 minus xt2 equals to k equals to this function, which mean t is lambda t and r t1 t2 equals to lambda square t1 t2 plus lambda minimum of t1 and t2. In the Poisson process, the points in the non-overlapping intervals are independent. And we can find that its mean t is lambda t, which is a linear function of t. We can get that the longer time we wait, the expected number is larger. Second, we are going to talk about the Poisson increments. With xt, a Poisson process defined above, and epsilon greater than 0, a given constant, we construct a new process, yt equals to xt plus epsilon minus xt divided by epsilon. Pxt plus epsilon minus xt equals to n, which equals to this function. And the mean t equals to lambda. Ry t1 t2 equals to lambda squared when the absolute of t1 minus t2, which is greater than epsilon, and equals to lambda squared plus lambda divided by epsilon minus lambda times the absolute of t1 minus t2 divided by epsilon squared, when t1 minus t2's absolution less than epsilon. In this one, we can find that its mean, which is lambda, which is a constant of the average rates, which is not influenced by the time t. The third one, which is Poisson impulses. We define a stochastic process zt as follows. Zt equals to dxt divided by dt, which equals limited epsilon in approach the infinity yt. Mean of zt, which equals to lambda, and rz t1 t2, which equals to limitation epsilon to the 0, and ry t1 t2, which equals to lambda square plus lambda epsilon t1 minus t2, which we can also find out which mean is lambda, which is the constant of average rate. It also will not influenced by the time t. The fourth one is semi-random telegraph signal. The stochastic process is defined as follows. Xt equals to 1 when k is even in 0 to t, and equals to -1 when k is odd in 0 to t. Mean t of it, which is e to the power of -2 lambda t, and r t1, t2, which is equals to e to the power -2 times lambda times the absolute of t1 minus t2. The fifth is random telegraph signal. Let alpha be a random variable independent of xt, with p alpha equals to 1 equals to p alpha equals to -1, which is 1/2. We form a new process yt equals to alpha xt, which is mean equals to 0, and rt1, t2 equals to e to the power of -2 lambda times the absolute t1 minus t2, which mean is 0. So we can always think that its average is 0. The sixth, which is random walk. If we toss off a fair coin infinite times, we can get this. This is one sample, which we can get HH, head, head, tail, 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 head, at T, at 2T, at 3T, at 4T, at 5T, at 6T. And we can get that XNT equals to KS minus N minus K times X, and which is 2K minus N times S, which K is the number of times of the head, and N minus K, which is the number of times of tail. So xt equals to xnt for nt less than t less than n plus 1 times t, and its density, which is p xnt equals to rt, which equals to this function, and its mean is 0. Rx nm equals to minimum of nm times x squared. Besides random walk, which we can see that is also a Markov chain, the current t is only influenced by the previous one t. The seventh, which is Wiener process. We define Wiener process as a limiting process of random walk. Wt equals to limitation of x to the 0, t to the 0, and n to the infinity of xt. The second moment of this Wiener process, which is finite and non-zero. The density of it Fwt, which equals to 1/2 plus EIF W divided by root of Ft. Fwt, which equals to 1 divided by root 2 pi Ft times e to the power of negative W squared divided by 2 Ft, which mean is 0, and Rw T1 T2 equals to minimum of T1 T2 times alpha, which mean is of 0, is not influenced by others.